Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be talking about reverse engineering or designing based off of a mesh reference. So the term reverse engineering is going to be a little bit of a misnomer here because we are not going to be pulling data directly from the mesh. We'll talk about what kinds of things we can do and what kinds of things we can't do. I also do want to note that we're using Plasticity 24. And the version 25 should be released soon, which does have a couple things that'll be helpful to us, things like section view. But for right now, this should work in whichever version of Plasticity you're using. I'm going to try to get a mesh reference into the description of this video that you can download, but hopefully even if you can't download that, you'll be able to understand the process. So the first thing that we want to do is start a new file and always double check our units. Even if you always work in the same units, it's a good idea to just double check what unit system you're working in. For me, I'm going to work in millimeters here. We'll delete the cube, we'll hit / to zoom in, and then we're going to go to import append. So in import append, I'm going to go ahead and bring in the mesh reference, and this is going to be an STL file. So this is not a great mesh. It's pretty low quality. The scan was okay, but it was only a partial scan, so the mesh software kind of filled in some holes. So it's not a great starting point from a reverse engineering perspective, but that's okay because again, the tools that we have here in Plasticity are going to be somewhat limited for this, but we're going to talk about that in just a moment. Thankfully, this mesh was already aligned to a coordinate system, so it's sitting directly on my XY plane. So all I have to do is right click to accept. So now that I've got my mesh reference in here, we need to start building out a profile or a section that we can revolve to build this. This is where it gets a little tricky because we don't have a section view and we can't really slice through the mesh. So we're going to have to do a little bit of trickery and kind of rotate things around. What I like to do is select a plane. So for example, the XZ plane, I'm going to double click on it. And this is going to make it active. So if I rotate, all I need to do is click on it over here and double click, and it'll go back to that view. So I'm going to start with a line, and I'm going to start it from the origin, and I'm going to come all the way to the top. And I'm not going to enter a value, but I want to make sure it's vertical. I'm going to left click, then right click to accept. Now, the reason that I did this is because whenever we're talking about reverse engineering, we need to think about precision. We need to know that we can enter specific dimensions and know that we're building the part correctly. That's a little bit trickier in Plasticity than it is in some other programs. So this is something that's very important we understand how to do. So what we're going to be doing here is we're going to use the tool to add the measurements. So I'm going to hit F to find, and I'm going to start to say measure. And measure will give us control plus equal as the shortcut key. But I'm going to click on this, go from this upper vertex to this lower one, and you can see we've got 10.619. Now, with using the measurement tool, when we've got something like, let's say, a solid box, we are able to use this measurement tool to drive the shape by using move. In this case, if I use move, and let's say try to move this in Z, well, I don't really have the option to click on the dimension. So if you haven't seen that, I'll just show you a quick example here. Using the box as our example, if we use control and equal to measure this edge here, you can see that it's 15.007. If I click on this end face and use G to move it, I can actually click on that dimension and manually enter a value of 15 to get it exact. So that tool can work really well in some instances. For us, it's not going to work well at the sort of sketch curve level. So what we need to do is we need to say that this here is 12.657. If I wanted it to be exactly 12 millimeters, I would say G, Z, minus 0.657 and hit enter. So what that's going to do is it's going to move that point in Z direction only down a negative value of 0.657. So in reality, that's probably going to be the best way that we can start this layout process. Now, this is actually going to be 10.5 millimeters. So what I need to do is G, Z, and what I can do is 12 millimeters minus 10.5, and that'll give me the difference that I need. So we can do those mathematical operators here, or I can just put a negative value. So if we want to go, let's say, down to 10.5 here, we can get there close manually, and we can see that now it's at 0.487. Or we can then go GZ.013 and hit enter, and that'll get us the rest of the way. So again, depending on where you're at with your dimensions, you could do mathematical operators like addition and subtraction to get that value. Or if it's close, you can just manually enter the difference in decimals to get it to whatever number you need. So 10.5 is the overall height of this impeller. So this is a little plastic impeller from a KTM water pump, and the bottom of it's got a little dome and a dish to it. And what the scan didn't pick up very well is this is actually, there are two flat spots here to key it to the shaft, and the bottom part is actually round. So we're going to put the hole in this thing at the end. We're going to just draw it as a solid for right now. So I'm going to take my line, and I'm going to come out to the right. And again, if I know the diameter of this, so I'm going to zoom in a little bit. If I know what the diameter is from measuring it, then I can enter that by hitting tab and then manually put in the value. So if I know that this is, let's say, 11 millimeters, I can do 5.5 because this is the radius value and hit enter. So now I know that that line is correct, but I can use control and equal to make sure that I have a dimension so I can track that and make sure that it's okay. The measurements here on the left-hand side can be toggled on and off, and if you delete the curve, then the dimension will go away automatically. Next, I'm going to add another line. This upper section, in reality, actually sort of flares back under, but I'm going to just draw it straight for the purposes of our video. I'm going to put a straight line there, right-click to accept, and then I'm going to use the line and come out and to the right. We are going to cut away from the bottom, but I want to get the diameter correct, so I'm going to say tab 20 millimeters and hit enter. This is just going to be a reference point for me. I'm going to delete it in a moment, and then we're going to come up from here, and this one is going to be a distance of 2 millimeters and hit enter. So let's move this over to the right or the left a little bit, delete that line. We'll do control equals and just keep track of these numbers. The reason the measurements are important is because if we happen to move points accidentally, the dimensions or the measurements are going to update so we can get an eye on that. So what I'm going to do here is this section is fairly flat for just a few millimeters. I'm going to go ahead and place it there. And then I'm going to use bridge curve to go from this point to this point. So this is going to be a tangency up here, let's say G1, and this one we can leave at G2. That's pretty close. It's not perfect, but we could play around with it. So if we're not happy, we can hit escape, move this point up, GZ, and then I can redo my bridge curve, going from one point to the next. And once again, this upper one, I'm just going to make tangent. This one down here, we can set to tangency, and that looks like it's a pretty good match for that curvature. Again, we don't have a section view, so I'm kind of just going off of looking at it visually. Another thing that you may want to consider with mesh bodies, we do have the ability to snap to them. So we could start to draw, and you can see here it says face XZ. And what this allows us to do is it allows us to start drawing a curve, making sure that the cursor says face and XZ on it. And what this will allow us to do is it'll allow us to snap to the mesh, and the mesh, the curve that we create should be on the mesh as well as in the XZ plane. Now, while this is very beneficial, I've actually found this to be a bit more difficult with a part like this because I don't really have a clear reference here, and it's hard to see because of the impeller blades and things on this. So I found it's actually a bit trickier to do for a part like this, but in some instances, drawing directly on the mesh is going to be a good solution here. Now, the other thing that we need to do is we need to deal with what's happening on the bottom. It's not flat, it kind of arcs up, and it's not just an offset of this curve. Even though it probably is in a portion of it, it's not an offset completely. So what we want to do, because none of these curves are joined, is I'm going to offset this with O on the keyboard. I'm going to come down a distance of -2 millimeters. That's going to be the thickness I'm working with, and hit enter. And I'm going to temporarily hide the mesh here. So basically what we need to do now is, because that distance was 2 millimeters, this should be tangent right here. I'm going to hit right click to accept. And then we just need to figure out where the step happens so that we can create the extra geometry here. So on the water pump, if we rotate this around, we can see that the curve kind of goes under the mesh, then over the mesh. Again, this is not a great scan to start with, so I'm not too worried about it being a little bit off. But we want to start on this curve and make sure that we are still seeing XZ next to the cursor. That's going to be important because we want to make sure we stay on plane. If you're using just the numpad 1, 3, or 7, a lot of times it'll jump away from that plane, but using these default construction planes for XZ will get you closer. So I'm going to go to about there, and I'm going to just actually, let's go ahead and do this one more time. So find that position where we want, let's say here, and we're going to come all the way to this point. It's saying closest, we'll right click and accept, and then we'll hide the impeller. So the reason I did that is, again, what we're going to be doing is going back and adding the hole after the fact. So now we can use our trim tool, which is going to be T on the keyboard. We can trim that away, trim this away, right click, and then I'm going to select all of these. So hold down Shift or Control. We could also box select them all because we don't have anything else. We want to join them together. So that's either J or this little icon down here. And then if we want to at this stage, we could round off any corners. I'm going to leave them square for now, and I'm going to round them off later. So now we can select our profile. We can use Revolve, select the origin, and then just come up along this vertical axis and right-click to accept. We can hide our polylines. And now what we have is representation of the solid portion, the hub portion, and we can see how close it matches. It's a little bit high here, a little bit low here, but again, not an ideal scan. You can see that it's high in this spot and it's high in this spot, but it's low here and it's high here. So the scan alignment and the quality of the scan are obviously going to have an impact on this. Now, if we are using this technique to, say, reverse engineer something, we would want to go by the measurements and use those measurements for any critical features, where the curvature here on the inside is not a big deal. It's more important on the bottom or the back side based on how this thing fits in a water pump. But again, these are details that we would need to capture. The next step of this, I'm going to get off of my construction plane and actually go to a top-down view, which is going to be XY, so double-click on that. And what we're going to do is we're going to draw one of the impeller blades. So to do this, I'm going to use a spline curve. I'm going to oversize it because I want to trim it back. So I'm going to do this with 3 points, right-click to accept. And then from here, we're just going to make some adjustments. So G and G on the keyboard to move it around. It's going to be hard to see, but we want it to roughly match the shape of the impeller blade. So once we're happy that it's close, we'll rotate around and we'll extrude this. So you can use E on the keyboard, or you can click on extrude here. I'm going to pull it up and right click to accept. So again, overbuilding it. Now that looks pretty good, but we might want to make some tweaks or adjustments to the shape because in reality, these generally aren't just straight extrudes. And there are a couple ways that we can do this. I'm going to turn off X-ray just so that the screen isn't as busy. I'm going to turn off my revolve solid as well. So one thing that we can do is we can raise the degree. So select this, hit F to find, and type in raise degree, which is Shift and S. And what this is going to allow us to do is it's going to add all these control points. And these control points allow us to now deform the shape. So what we want to do is select, let's say, these upper control points. I'm going to use rotate, which again, you can select down here if you want, or R on the keyboard. And with this, I want to change the pivot point. Now the pivot point in the bottom right-hand corner is going to be the shortcut key V. I'm going to place it over here. I'm going to rotate this around. And the white ring is going to be based on our view. So as long as I'm looking at it roughly from the top, I can start to rotate this blade. So you can see it's sort of twisting. So again, this is a great way to get a complex surface that we can thicken. And if we need to move the entire thing, so G and G, I'm going to bring it in until I'm on that inside face. And then you can see here what we may need to tweak or adjust. So it looks like maybe these points over here could be moved G and X, kind of pull them back to the right a little bit. And that gives me a pretty good representation. Now, some of you might be thinking, we have something called constrained surface. We've talked about this in a previous video, and constrained surface is a way that we can draw a surface directly on the mesh. So I'm going to show you that now and show you why it's not a good solution for this video. So F, and then start to type in constrained surface. And then basically what we do is we pick points on our mesh, and then we can right click and accept. So the problem with the constrained surface is, one, our reference isn't great. Two, we have all these rounded corners and edges that won't let us properly overbuild the surface. If we try to adjust this with, say, raise degree, we can still do that and move it around, but it's already got more subdivisions in it than a simpler solution of just extruding a surface and then tweaking it with raise degree. So this is an option, and it may come in handy with certain types of models, but in this case, it's actually going to be more problematic than it's probably worth. So that's why I decided to use the extruded surface option rather than using a constrained surface. So at this point, now all we need to do is thicken this. So F to find the tool, thicken, and we'll select the thicken tool. And again, this is going to be 2 millimeters. That's sort of the default value that I'm working with here. So -2. And you can see here, it looks pretty good. It matches the inside. It might be hard to see, but it matches the inside pretty well, matches the outside. At this point, we would need to think about how we want to trim it down to the correct size. Now, there are two schools of thought here. You can cut it after the fact using something like just a curve and an extrude or the cut tool, but it's likely easier for a model like this to do this when it's a surface model. So what I mean by that is we can do Control Z and undo before this. We can rotate around until we're basically looking at that blade, and we can create a plane from our camera view. So in the camera view, I want to make sure that I don't attach or do anything to this corner over here. But basically what I want to do is figure out where I want to trim this and make sure that it's larger than my surface. And then we can use the cut tool and select our target body and then get rid of this upper section. All right, so now that we've got it cut, once again, we can use thicken. We're going to say -2 millimeters. And now we've created that solid. You'll notice that because we overbuilt the surface and we cut it away, we still have all the control vertices here that allow us to adjust or tweak that shape. Now, if you want to get rid of those, what we can do is type in toggle points and turn them off if you just don't want to see them. They will show back up when we're doing things like a radial array, but for right now, just turning them off is going to be a good option. So I'm going to bring back my solid. I'm going to hide this point here. I want to cut the outside of this with the cylinder. So I'm going to select the body, C for cut. The tool is going to be this outside cylinder, and then we want to get rid of this outside piece. Again, you can see whenever we're modifying it, this pops back up. Now we want to round these corners off. So I'm going to select this and start to add a fillet there. Do the same thing over here, round it off. And now I want to do a radial array. I'm going to bring the mesh back so I know exactly how many I need, but we'll do a radial array. And select a cylindrical point. And it looks like we've got 6 here. And again, you can see the mesh reference isn't great. It's a little bit off center. The mesh repair is a little bit off, but you can kind of see where all those land. Right click to accept. While they're all selected, we can hit Q on the keyboard, Q again, and shift and select the center. That'll join them all together. All right, again, I want to do toggle points because I don't want to see all that. And now we need to round the corners off. One thing you'll note that happened is the blade actually on the bottom was too long. Now, because we kept the original curve, we could use that to actually cut away the bottom if we want, or we can use some direct modeling tools like selecting faces and deleting them. So we can select a couple faces. Let's rotate this around. And it's gotta get to this side as well. Select these. And we should be able to delete and clear that up. Now that's obviously a pain and problematic, so the easier thing is to back up a couple of steps, just using undo before the radial array, before we created that. And then what we would want to do is get rid of the bottom of it. All right, and the way to do that is we can use the cut tool again, so C for cut, hold down Shift to select multiple bodies. And if it has any problem, sometimes what you can do is you can duplicate a face, so Shift and D. And then we've got a cutting tool that's a surface, so C. And then our cutting tool is going to be our surface. And sometimes this works okay. If this doesn't work, then there's a potential problem with the outside here, which means that we may want to offset the outside edge or like extend the sheet a little bit and try again. So C, and then my target and tool bodies, right click to accept. And if this doesn't work, then the last thing that I would likely try is to grab this curve. And what I want to do is unjoin the curve, so Alt and J. And then I really only need to use this portion here. But what I'm going to do is I'm going to make that portion, let's go back to this view, I'm going to make this portion extend out, and I'm just going to turn it into something that I can use to extrude. So select these, join them together, and now I've got this profile that I can revolve. So revolve or extrude depending on your geometry. And what we want to do is we want to cut that away. So this is going to be a Boolean, so Q, and remove that bottom part, hide all of our curves. We'll bring back our revolve solid, and now it should match the bottom. And you can also do this with the top face as well. But now we can do our radial array once more. We should have 6, Q and Q, shift select this to join them all together. And then we're going to do toggle points. All right, so everything's looking better. The outside is smooth here. There's some stuff on the bottom. What we can do is try to do delete redundant topology to see if we can clean up the bottom a little bit. And you can see some stuff got cleaned up. There's still some of these sections here that are divisions. We can select them and just delete. And Plasticity is pretty good about cleaning that up for us. And now it looks pretty good on the bottom. All right, so now that we've got all these blades here, we're going to add a few fillets. So at the root here, we want to blend this out. I'm going to turn X-ray back on so I can see through and select these other edges, make this process a bit quicker. Grab this one here, that one, and this one. And then we'll right click, and then I'm going to add another one here, just a little bit smaller. Control, and then just kind of work my way around to the top edges of all these. Some of these we could have added before we did our pattern. You'll notice also I didn't blend it down here. We could add those if we wanted to blend it in and just work my way once again around. With X-ray turned on, it makes this quite a bit easier. And then right click to accept. And the last thing that we need to do is pop the hole through the center. So this one's pretty easy. What we could do is I'm going to select this top face, hit spacebar to create a temporary construction plane, and then I want to hit tab and create a 6mm hole. And then we would just extrude it down through. This one is going to be a difference, so W, and select the main body, and then X to get off of our construction plane. Now, I did mention that this actually has a square profile in the top section. I'm not going to put that in this model, but you certainly could. And then if you want to add any other details, so this is actually rounded off in the model, and so is this bottom edge, it's kind of rounded. And this section here, and then there's a little bit of a chamfer there, and a little bit of one at the top, probably not that big. Let's go ahead and remove that one, and then we'll just add a little one here. So now what we can do is we can go to maybe a different view. We can hide our edges and just take a look at the final model. So if we bring back the original mesh and let's just move it off to the side, you can see that there are pretty good representation of each other. Now, obviously there are different areas where I skimped on. Again, we would need to use real measurements and make sure that we understand precise features like the outside diameter, the actual hole through the center, and if there are any threads, those kinds of things. But in terms of the general geometry, this was a fairly easy process to capture the details we needed And then we could recreate this part. We could 3D print it, see if it fit, and go from there. Now, again, I do want to make sure that we understand the disclaimer that when we say that we're reverse engineering something, we're not using sections of the mesh. We're not pulling out data directly from the mesh, but we're using it as a reference in a 3D modeling environment. Remember, if you're looking to purchase Plasticity, we are an affiliate. And if you want to save 10% and help out the channel, you can use the code LEAD10 at checkout, or you can go to the description of the video. We'll put a link and the code in there that you can use. If you have any questions on things that you want to see with Plasticity, please let me know. We have currently one Plasticity course on our learneverythingaboutdesign.com website, and we will be adding more in the near future. We're just waiting for the update of version 25 to come out before we put new courses out for that website. But again, any questions or comments, please leave them on the video. As always, thanks for watching, and we'll see you in the next one.